record. You'll see two squares. And they are, one of them is 8 by 8. So it's got 64 square units, probably inches. Maybe centimeters. I haven't actually measured it, but it's units, so they are uniform. And the other one is 13 by 13, so it's 169 square units. So what I want you to first do is take your scissors and cut out each square. Just put your scrap paper over to the side. I'll get clean it up after class and put it in the recycle bin. So cut out each square. Cut this square out, cut this square out. Around the border. All right, almost there. Okay, once you get the two squares cut out, you will note on each of them, and they're identical in terms of how they mark their better word that proportional. Similar, but there are dark and black lines on the side. And so basically, this square here is made up of two triangles and two parallel, or not parallel rings, but triangles. So what I want you to do is now take your scissors for each of the two squares, and you're going to cut out along those lines. So be careful to cut along the line here, line here, line here, to get the two trapezoids and the two triangles for each of the two squares, and keep those pieces together so you'll have four pieces, two triangles, two trapezoids, and such. So cut out again on each of the two squares, and so you've got four pieces. This is the bigger one cut out right here. So cut those out for each of the two squares. Okay, almost got one there. All right. So once you have both of them cut out, so you've got your the safe just for the look at the big one, 13 by 13. Take it first. And now what you're going to do, and this might be a little frustrating, you're going to take these four pieces and rearrange them to make a rectangle. Right? Take the 4 pieces of the big one, and they can be reformed, put together with no gaps, and make a perfect rectangle. You'll know it when you hit it. So I'm going to let you kind of play around with that for a few minutes. See what you can come up with. And if we're struggling a little bit, I'll give you a hint or two. Taking the 4 pieces and rearranging them so we've got a rectangle. All right, normally I would probably give a little bit more time and let you struggle with it, but I want to get to the geometry review as a whole, so I'm going to throw it in at you. Take 2 of, and it doesn't matter whether you take the pair of trapezoids or the pair of triangles, but take 1 pair, flip it upside down, both of them, and now try to rearrange. Take either the pair of triangles or the pair of trapezoids and flip them upside down. So you'll have 2 congruent pieces. Right side up, you'll see the grid, and 2, you'll just see the without the grid. See if you can hit it that way. We've got a winner. All right, so model her. So I'm going to go ahead and use the trapezoids. So I'm going to use the triangles. And yesterday when I did this, I had not actually, it had been a while, several years since I had done this activity. So, but I just wanted to know it will work as long as you get to, pair, flip, either the trapezoids or the triangle. All right, how you guys doing out there? So you guys can see what it looks like, what we're getting at. All right, so I'm going to see if I can point this camera down so you guys can see what we have. So there are the 4 pieces, 2 of them are triangles in this case, were flipped upside down and then pieced together into a rectangle. All right, now go ahead, once you've got that, you've seen this. Do it with a smaller one. Piece it together. It will also fit into exactly the same way into a rectangle. 4 smaller pieces and form it into a rectangle. Okay. Now here's some mathematics. So the big square, what we cut it out? 13 by what? 13. 13 units by 13 units. So its area was 169 square units. Cut it out along the specified lines. the rectangle that we just formed for the big one. What's its dimensions, length and width? Dimensions of the rectangle. Twenty-one by eight? Yeah. 21 by 8. It's 21 times 8. Length times width, area of a rectangle.
$168.
168 square units. Is that a problem? Problem. What was the area of the square, the original square before I cut it? It was 169 square units, definitely. Cut along the specified lines, rearrange it into a rectangle, so all I did was take those 4 pieces that made the square, reformed it into a rectangle, and I lost the what? I lost the square unit. So it's like, okay, so basically I just defied the laws of physics. I just made matter disappear. Definitely that's what the numbers are saying. All right, let's look at the small square, the 8 by 8. So 8 by 8, its area will be 4 square units. The rectangle we formed there has what dimensions? What is the area of the dimensions of the small one? 13 by 5. That is it. 13 by 5. So its area, 13 times 5, 65, is 65 square units. All right. So for the small square that we cut in and reformed into a rectangle, now we have created matter. It's got an extra square unit. I mean, it's third bit. When it comes to it, mathematics. So like any good magic trick, it's an illusion. But it's not really taking away matter or adding matter. Basically cutting along those lines in this particular case, every time you cut down, notice you're cutting through those little 1 by 1 squares that you cut down through there. In this particular case, when you put them back together, there's actually a gap there that would add up to 1 square unit total. Or that one has the gap. This one is all, when you put them together on the big one, you are, it actually kind of overlaps a little bit, but adding up to exactly 1 square unit on the overlap. And so it just looks like it's this is where, either gaining or losing a whole square unit, but but you have to cut along those very specified lines. Now, one last observation. What was this called? Sequence. Name of that sequence? The Italian guy's name? Fibonacci. It's a Fibonacci sequence. So we obtain it. How do we get the next term in the sequence? We add the 2 previous consecutive terms, right? Get the next one. 13 and 8 are both what? Fibonacci numbers. Then when it got reformed, like 13 by 13, it went what? 13 by 13, it reformed into what? 21 by 8. And when I took the 8 by 8, it reformed into what? 5 by 13. So Fibonacci's next thing there. All right. So wanted to show you that, and just that I haven't actually got to do this activity since March 20. Um, and, but looking at just as a classroom activity, just as one example of what you can do. All the things I got to review on here, that trapezoids, right? Triangles, congruency, similarity. Plus it is kinetic. These are hands-on. Working with spatial. That was fitting them together. Right? Like a puzzle. And then I got to mix in Fibonacci. So when you are working with kids, one of the first things you kind of figure out is, and it is what it is, it's if you don't have it, you're not going to have much of a class. And that is keeping control of the class, discipline, keeping them on task. So, and I had to figure it out the hard way in terms of what works and what doesn't work. So you can take classes on, say, like assertive discipline, cracks me up. Put your hand up like this, and they're all wave at you. What you're gonna do. But back when, way back in the Wayback Machine, 30 some odd years ago, I actually double majored. I was English and I was math. 5 through 12 each, got a certification for each. So when I did my student teaching, it was split. I had 8 weeks English, I had 8 weeks math. My English placement, high school, senior, honors, English. I'd do it forever. I just say, whatever I said, they did, and the high school teacher did what was supposed to be done, kind of built me up to taking the whole course of a whole class of the day, and then kind of weaned it back down. My second placement, and the next 8 weeks, 7th grade math at a low economic, socioeconomic school. I lost my voice for the first 3 days. The teacher of the classroom, and I learned a lot from her, but I think she was a little burned out. She did not approach things the way it was supposed to be. So basically, I showed up that first day, and she said, "Here you go." And they had a smoke room, and that's where she took off to. And all of a sudden, I was stuck with these kids. Shouldn't have happened, but nothing went awry. But again, within 3 days, I lost my voice. On day 2, I went and got an application from GREA. I need to work with the dogs. But at the end of that term, I figured out how to work at that age group. It was exhausting. I still got the yearbook, they gave me a yearbook, and they all signed it, and that just cracked me up because everyone was like, "I'm sorry, I didn't say that." And but what I figured out was you got to trip and learn. That's where the exhaustion comes. You got to pick up things like this, find things like this. Now you have an advantage in what I did not have, which was the internet. I mean, you can instantly find all kinds of stuff to do. But then just one other side that, and I still have the VHS tapes, and maybe I want digital. University supervisor came to each class once, unannounced. So, and it was just so random that it happened to be that I was wearing the same outfit both times. Which I look back at it now, boy, that was ridiculous. So I had like this corduroy jacket, so brown paisley tie, like a white shirt, jeans, cowboy boots, and my hair was considerably longer. So, but the high school, my tie's all nice and tight and crisp, hair is all neat. I just going around the room like the greatest teacher ever. And then you look at the video of the middle school place, ties down here. My hair literally is just look like Einstein. But anyhow, so any questions on this little exercise? Then again, remember you have the email, so you've got this. So this is an example of one of them. All right, any general questions? And otherwise, I'm going to go ahead and talk about geometry. For reviewing. Good, all right. Well then. So what I just did yesterday for the geometry, I just went in to the geometry problems on the Homework Review. So again, you'll see it's 32 problems total. Okay, so the geometry portion starts with number 23. This is actually from the review. So for you guys there, I'm going to try to just, since you really can't see the my math lab very well, I'm going to try to write the problems up here as I can. Let's talk through them. So on 23. You're getting a line with about 4 points on it. You have S, T, U, and B. Now you're asked to find, and the notation on this problem isn't the greatest. If you take segment SU, line segment SU, and it kind of looks like after that, looks like some sort of fish hook or something. What it is, it's supposed to be a union symbol. But notationally, this thing is connected to the end of the point of the line segment for UB here. That U's kind of hooked in there, so but it is union. So remember, union means what? Dump them all together. Big hat. So you got a set of points here, SU. You got a set of points here, SU, and a set of points here, UB, right here. So if I union these up, what line segment would you have? That is your union SU, this set of points, and with this. Put that together, what line segment? So they give you 3 different line segments to choose from. And then the 4th choice is the empty set, that is, it's no points. So in this case, which line segment would be the union of those 2? I'm sorry, B. Did you say what it be? That's exactly it. So it's going to, if you got this union with this, you're going to end up with SB. So it is the. All right. And I checked C. There's. Okay. Next question. Supplementary angles, complementary angles. So in each case, it's a pair of angles. But if you're talking about complementary angles, it's 2 angles whose measures sum to be what? I'm sorry.
Which one did you say complementary?
Complementary.
Complementary.
Yep. All right. So the complementary angles are 2 angles which sum up to be 90 degrees. Supplementary angles are 2 angles whose measures sum up to be 180 degrees. So in this case, on number 24, it's asking find the complement of 57 degrees. So if you are given an angle and you're asked to find the complement of it, just take that number away from 90 And what you're left with has to be the common, because they would have to add up to be 90. So in this case, it's 57 degrees. So it's just going to be 90 minus what? 57 degrees. And what is 90 minus 57? 33. So that would be your common. If you were looking for the supplement of an angle, when you're given the angle, you would take it from 180 degrees. All right. Next problem, 25. All right, so here we are given a geometric situation. You've got this angle marked as 4x plus 47 degrees. This angle as 7x plus 5 degrees. All right, so again, we're reviewing here. What? This pair of angles here, what are they called? This geometric situation. This pair of angles that's marked, they have a name. Begins with the letter B. Vertical. They are vertical angles. Vertical angles are the non-adjacent angles formed by the intersection of two lines. And it just so happens by theorem that they are what? Equal in measure. So here you're asked to find the measure of angles and what they are. And so the geometric principle is you would set this equal to this. That is 4x 47 equals 7x plus 5 and solve for x, linear equation. So I'd bring the x over this way, that would give me 3x. Subtract 5 from both sides, that would give me 42. Then divide both sides by 3 to isolate x. So that's going to be what, 16? Okay. 42 divided by 3 should be 16. Now, it says find the angle, not x. So if you chunk 16 in there, it's going to count it wrong. But since these have to be the same, take either one and put 16 in there for x. That is, I'll just go 4 times 16 plus 47. And what is that? It's going to be 64 plus 47. One 11. All right, so that's got to be it. 111 degrees would have to be the measure of each of the two angles. Something's not right. Write it down, right? So, oh, shoot, my bad. I knew there was a mistake somewhere. 3 divided into 42, not 16 times. It's 14. I apologize for that. So that should be 14 here, so that's 4 times 14. Is that right? Yeah. And then what's this now? 4 times 14 plus 47. That's 103. All right. Arithmetic. All right, 103. There we go. All right. So, all right, next question deals with convex or not convex. The book uses, and they give you something that looks like a ellipse. It asks is it convex or not convex. Now I said I gave you another term for not convex, and that was concave. It's not convex, it's concave. Which one do you think this would be? Yes, convex, that is, if you have like an ellipse. Is that a convex figure or a not convex figure? It is convex. This is convex. And so the actual geometric test, and when I think concave, there's a portion of it that is like caved in. Like this would be concave, or it's like not convex. But the idea of if it is convex, you can pick any 2 points on the interior and connect them up with to make a line segment, and the entire set of points that line segment stays inside, or any point you pick in there. But it is concave or not convex if I can pick 2 points and then connect them up, and portions of that line segment are what exterior. So, all right, that was 26.
Why don't they use the term concave?
I don't know. I have mentioned it to the publisher of the book for years. I'm not sure why. I prefer the term concave because in the name itself, it kind of gives an indication of, yeah, the portion of it's caved in.
That's how I learned it.
Yeah, so, but just never did. All right, so 27 deals with triangles. And classification. All right, and so by size, there are 3 ways to classify triangles. And you're given a triangle, it looks like this. And you're given side lengths of 24, 56, and 72. All right, so you're given 3 choices. What is, so before we choose, what is equilateral mean about the side lengths of? They're all the same, have exactly the same length. If it's scaling, then what do we know about the side lengths of the 3 sides of the triangle? If you classify triangles scaling, they're different. They're all 3 different. And what about isosceles? 2 of the sides have the same length. So in this case, all side lengths are what? Different, so it definitely is scaling. Right. Now, there are 3 ways to classify triangles by angle. Right, obtuse, and acute. If you have a right triangle, that means one angle is right, 90 degrees. If it's obtuse, then one angle is obtuse. An obtuse angle, by definition, is an angle between 90 degrees and 180 degrees. And if you are acute, then every angle, all 3 angles in the triangle is acute. Now, an acute angle, we just say less than 90 degrees. And the reason we can say that, I have to say between 0 and 90. In geometry, you put in geometry, all measurements are positively valued. Always lengths, measurement of angles are always positively measured. So you can just say less than 90 degrees. Now, you have to do this one visually. So looking at this triangle visually, would you classify this right, obtuse, or acute? Obtuse. This angle right here definitely looks like it's more than 90 degrees. So it's going to be obtuse. Check classifying it by angles. So you can say what scaling, obtuse, triangle. All right. All right, next one, circles. All right, so on problem 28, you're given a circle, and I'm going to put everything in here, best, doing my best to. Got a line here, this point is labeled A. It gives a point on that line E. Given a center O. Given line segment here, it's B, D. Going this way, it is C here. You've got a line going through here, like such. A line on this way, like such. All right, I think now I have everything labeled. So that is the picture you're getting. Now you have to basically go and identify parts of the circle. And the first one just says find the center of the circle. You're given 4 choices, points C, A, O, B. Go to the center of the circle. Circle is by definition all points in the plane that are equidistant from some fixed point. That fixed point is the center. Typically, if you're just dealing with one circle, the center is just labeled A. In this case, that is the case. So the center is A. Next thing it says identify radii. Now radii are line segments going from the center whose other endpoint is point of the circle. And radii are always what? Congruent, because it is that equidistant around. So there would be 4 radii. And the order at which you write points, like I could say radii OD, you could say DO, it's the same set of points. But it looks like OD, OC, OA, and OB. And that looks, as far as here, selection D. Are those 4 segments. Good, radii. Diameters. Now, in terms of how the order they asked these, I wish they'd asked about chords first, but they didn't. They asked about diameters. So they're going to ask about chords next. A chord is a line segment whose endpoints are points of the circle. Like AB would be a chord. Segment AB. But a diameter is a chord. So it falls into the set of chords. But it's a chord that passes through the what or contains the center. So here with here there are 2 diameters, either AC or BD. And that will be selection A. AC and BD will be your diameters. Now it says chords. Now, I wouldn't, if it were me making this problem, I'd just say AD and BC as my 2 chords. But this one, just so for reference, it's going to also have you include those 2 diameters, which are by definition chords. So there's going to be 4 of them. And when you look at your choices, there's only one. They only need to look because there's only one of the 4 choices that has 4 segments. It's got to be D. Right. So the 2 chords and the 2 diameters, they're all chords. Okay, secants. Secant is a line which passes through what? 2 points of the circle. That's a secant. So you would have line AB and line what? BC. And that looks to be selection B. And then it asks about tangents. There's only one tangent. A tangent is a line which only hits or intersects 1 point of the circle. And so it's got to be line AB. That's it. It's the only tangent listed. All right. That was 28. All right, 29. Deals with similarity. Given triangle like this and one proportional or bigger. And then we're told these two angles are congruent. And that this angle measure right here is 45 degrees. This is labeled B, P, W. This is X, Y, and Z. We're also told these two are congruent, and this angle is 61 degrees. It asks for the find then the measures of four based on the fact that they are similar. Measure of angle T, measure of angle W, measure of angle Y, and the measure of angle Z. All right. Now, what about T? What's it have to be? If these are similar triangles. Has to be 61. If two triangles are similar, then their corresponding angles are congruent. And the side lengths are proportional. So in this case, if that's 60 and this is their corresponding angles, they're congruent. This has got to be 61 degrees. Now it asks for W. How are you going to find W? Because it's not down here either. How are you going to find the measure of W? And take away from 180. Since the three interior angles have to sum to be 180, that plus that, which would be what, 106. What is 180 minus 106? I'm sorry.
74.
74. All right, there's that. 74 degrees. Now, if that's 74, then we also know that has to be 74, the corresponding. When you go find Y, it's going to be the same deal. These are corresponding. So this is 45, then Y has to be 45 as well. And then Z, we already know it's got to be 74. All right, similar triangles. All right, just for fun, I'm going to pop this in there. 74. 45. And 74. Okay, another one with similar triangles, but looking at side length. So number 30. I'm gonna triangle here and then one similar to it. Such. And I've got 6 and 4, 9, and X. All right, so if you have two triangles, they are similar, then the side lengths are proportional. And you can set up proportion various ways. I would just go 6/4. And then but keep the sides corresponding here, and that would be 9/X. Then solve the proportion, just cross multiply. That would be 6 times X. We have to equal 9 times 4, 6. I do 6, and X is 6. Uh, 31 deals with circles again, but area. And circumference. What's the view? What is the formula for area of a circle? That's it, pi r squared. And r is the radius. Okay, what about circumference? All the way around. That's it. All right. So each is based on radius. All right, so the first one, it gives you a circle. And says, so you see this, you see a diameter here, and it just has 8 yards. So they're saying that this diameter is 8 yards, which means the radius is what? 4, half. It's gonna be 4 yards. All right, so you have to actually give the circumference 2 ways here. And the first way it says type as an exact answer. That means don't get a decimal approximation. Leave pi as pi. So you just would plug in. You would say, okay, 2 times pi times 4. You can simplify that to 8 pi. Now, units would be yards. So what I now need is somebody there at the calculator. It says type in, or once you get this in there, it's going to want the decimal approximation to hundredths place. So it's 2 decimal places. So what is 8 times pi? And round it to 2 decimal places.
45.13.
Yeah. And just normal rounding here. So if thousandths place was 5 or bigger, round up. If not, leave as is. So when you type this in, you'll notice you've got pi in the toolbar. So you'll have 8 pi, you will select yards. Check the answer, then it's going to ask again, round to the nearest hundredth, and we said 25.13. Still units of yards. Okay. Now area. We're just going to do the same thing, different formula. So exact value here, we have pi and radius was 4, so 4 squared. So your area is 16 pi, and here it is squared units. All right, so same deal. Let's go ahead, get a decimal approximation, hundredths place. All right, so 50.27 squared yards. All right. This first one is what? 8 pi. No. 16 pi. And square yards. And then 50.27. And square yards. All right, last question. Is area polygons? It's what we call a composite figure. It's actually made up of a triangle and parallelogram. So I want to find the total area here. So you've got you got a triangle. Now, you're given this side length to be 8. This is perpendicular. It's going to be the height of that parallelogram. That's perpendicular down to here. It is also the height of a triangle. And it's going to be 2. It asks for your total area, but what you're going to do is find the area of each of these, add them up. So what is the area formula for a parallelogram? I'll put A sub B. I'm looking for just what is the general formula? Area of a parallelogram. What does that area formula look like? Any memories? Now, remember rectangles are what, length times width, right? And they actually, you can take a rectangle and use the same area for them. Because a rectangle is a parallelogram. Let's see if this runs about. Base times height. Where your height is going from a what, vertex to the opposite side perpendicular. Now, so if you've got a rectangle, it's just the height is actually one of the sides. There's still a height, and then the opposite side is the base. So I've got a height of 6, base length of what, 8. So this would just simply be 6 times 8, and then multiply this together for 48. Square units, I don't know what the units are. Okay. So what about the triangle? What's the area formula for a triangle? Now, if you got the parallelogram, it's half of it. So now, opposite side of this parallelogram also has to be 8. Opposite sides of parallelograms are congruent. And so you've got 2 here, you got 8 here, so it's going to be 1/2. 2 times 8. So altogether, that's going to be 8 square units. Now, your total area would have to be the sum of these two. That is 48 plus 8. So that'd be what, 56 square units. All right. That is it for geometry. So that is the end of the review. The only things I didn't put in there were spatial figures. So didn't put any kind of polyhedra, cubes, spheres, cones. What are the units when you figure up the space inside? It's not squared, it's not the power 1, it's not squared, it's what? Cubic. You're looking how many 1 by 1 by 1 cubes kind of stuff inside something. Now you can still talk about area, but it's surface area of the outside. Spatial figures, but it's not on the, we can put them on the review. Again, if it's not on the review, it's not going to be on the top. So again, work through this, make sure you have worked through every problem. If you have any questions or you want any help between now and through next week, email me. Now I will be apparently, so I'll be here tomorrow. Saturday, apparently I'm Christmas shopping. So pretty prayer for me. We're gonna get it all done. But if I do this, then I'm released to go ski. So I'm gonna plan to ski Sunday, and I'm actually gonna stay and ski through Monday. I won't during the day be available. But I will have my laptop, I got my phone, I will check my email at night. Probably ski Tuesday morning and then head back in town. I will be in town definitely Wednesday, Thursday, Friday, and I can be available on campus. So I'm just saying, if anybody wants to come to campus, just to work problems or have questions, I will be available those days. Just get a hold of it. Now, again, drop dead date. Absolute. Can't work past. That is what, 8 a.m. on Saturday. I will put final grades in on Saturday. Now, I will add sometime before Friday, I'm going to do management completes. If there's an assignment you've never opened since midterms, there will be a 0 in there, but you can still do it. Now, any assignment throughout the semester, if you want to try to improve your grade, you can work on any of it. up through that deadline. I can't say this enough. You have to take the final. It's a bad deal if you don't take the final, real bad deal. And this goes for any class. So basically, no final is not good, right? Not a good situation. So be sure you take the final exam. But again, strongly suggest you do that final review. One last note. Back in the olden days, last day of class, I would come in with paper evaluations and then just give them everybody. And then I would pick one person who would collect them all and take them down to the division office. And I would never, see them until after grade was. That was been a while back. We then we went to, they were bringing iPads in. It was literally to bring a cart and bring the iPads in. And so it was still not a problem. Once we went to just put them online, the students, would, on their free time, get in there and do evaluations. The problem is I don't get enough back to make them really worthwhile. That's really where I'm going with this. I've been, all I can do is ask. And what I'm really looking for there is, again, honesty. If there's things you like, tell me. Now there'll be multiple choice questions and how would you rate this? I really loved it. And okay, I really hated it. It's not exactly what they say, but it goes out and they're calculated. I get the percentage for each of those questions, but there's a place to actually write in comments, and that's where I really find the most value. If there's something you didn't like, and we have been all over the map with the pandemic, so I don't feel, and I was kind of not feeling well portion of the semester, so it's okay. I got broad shoulders, I can take it. I'm not upset. But what I want is this. I mean, if you think Cunningham's a jerk, okay, fine. Cunningham's a jerk. But tell me why. That's, because the whole point is, how do I fix it? So if I know what it is and why you didn't like it, then I can think about how can I do it. And so it's just for me personally, at this stage in my career, I actually don't have to evaluate all my classes, but I do. Or I want them all evaluated, so I want that feedback. So if you just sometime between now and before the end of the semester would do that, I'd appreciate it. So are there any other questions from anybody? Okay, if not, then I will go ahead and